I'm back. All right, let's change that a little bit. Okay, this section is 4.3 slope-intercept form. Now, we've met slope-intercept form before. I've used it. You've seen it in Alex. We used it in 4.3. So hopefully this section is going to be pretty easy for you. Slope-intercept form is a wonderful tool because it makes it possible for us to graph lines without having to make those tables. Nobody likes making the tables. So the easiest way to graph a line is to put it in slope-intercept form and then just graph it. All right, we do have a secret word this time, another scramble. So you want to write down the letter E. We're looking for block letters like this. First one is E. Okay, so here they're explaining that an equation in the form y equals mx plus b, m would be the slope, and b would be the y-intercept. So if we had an equation that looks like this, see, we have y equals negative 2x plus 7. What we know is that the slope of this line is negative 2, or negative 2 over 1, and we know it intersects the y-axis at 7, which makes it completely possible for us to just go ahead and graph this without having to find a bunch of points. One of the things they are going to ask you to do in this section is they're going to give you the slope and the y-intercept and ask you to write the equation. Okay, so for example, if I told you that you had an equation with a slope of 7, you just go y equals 7x, and the y-intercept is negative 1 minus 1. That's all you have to do. Over here, they're giving you a slope of 4/7 and a y-intercept of 5. So you put the 4/7, the slope, in front of the x, and the 5 at the end. All right? And what do they mean by simplify? What the heck they want us to do that? I don't know what you'd put there. All right, so the check, write an equation for a line with a slope of negative 5. So we do y equals negative 5x and a y-intercept of 12. And they didn't say negative 12, so we have to assume it's positive 12, and we put plus 12. I guess maybe you just write 4/7 x plus 5 without the parentheses or something. Who knows? Reveal. Okay, now sometimes the problem will be that the equation is not in slope-intercept form, and then it's just a matter of manipulating the equation to get it in the form we want. So they've given us this equation, and it's not in the right form. To get slope-intercept form, we want y all by itself on the left. On the right-hand side, we want the x term first, and then we want the y-intercept last. Okay? So the first thing I notice is that the x term's on the wrong side of the equal sign. It should be over here with this 4. So the first thing I'm going to do is add 22x to both sides. That's going to give me 8y equals 22x plus 4. Y plus 4 because this was a positive 4, right? Now, we always have to have y completely by itself. It cannot have a number in front of it. So what we're going to have to do is divide every term on both sides by 8. And that's going to give us y equals, well, 22 over 8 reduces to 11 over 4. So we'll go, we always want to reduce our slope as much as possible, x. And this reduces to 1/2. So it would intersect y at 1/2, positive 1/2, and the slope would be 11/4. Okay. What is the slope-intercept form of this equation? I'm going to write it over here so I have room to work. This one is pretty much set up the same way as the first one. This x term is on the wrong side. It needs to be over here. How do we do that? Well, we get rid of it by adding 16x to both sides. Now I have negative 4y equals 16x minus 56. All right? My last step then is to get y by itself. It can't have a coefficient, so I need to divide every term on both sides of the equal sign by negative 4. All righty, and these 4's cancel. 16 over negative 4 reduces to negative 4 because 16 divided by negative 4 is negative 4. And negative divided by negative, this is positive, and I want to say this is 16. 56 divided by 4 is 16. I think that's right. And that's our equation. We would start with a y-intercept of positive 16, and then we would use the slope of negative 4 over 1 to find the next point. And I'll show you how to do that too. And of course, then in good old reveal, oh, wait, did I tell you? Make sure you wrote down that F. Did you write down that F? Okay. I hope so. All right, now we have an I. Write down the I. The number of job openings in the United States during a recent year increased by an average of 0.06 million per month since May. In May, there were about 4.61 million job openings in the United States. Write an equation in slope-intercept form to represent the number of job openings in the United States in the months since May. Okay, so you were given that there were how many million job openings in May? There were 4.61 million job openings in May. All right, I don't have my answer key, so I'm not sure what they would put here. Let's come back to that. Because the number of job openings is 4.6 million when X is 0, when time is 0. Oh, let me get the stupid book. I don't know what words. Okay, I have the answer key. Oh my God. Could they make this any more complicated? All right, so 4.61 million job openings in May is right. Here they want you to write, let X equal the number of months since May. The number of months since May. I don't know how I'm supposed to know that. And Y equal the number of job openings in millions. Okay. Because the number of job openings is 4.61 million when X equals 0, and B equals 4.61, and because the number of job openings has increased by 0.06 million each month, then they want you to write M equals 0.06. That's the rate of change. So the equation Y equals 0.06x plus 4.61 represents the number of job openings in the United States since May. Could they make that any more complicated? Okay, whatever. Moving on. In the first quarter of 2012, there were 183 million users of a popular social media site in North America. The number of users increased by an average of 9 million per year since 2012. Write an equation that represents the number of users in millions of the social media site after 2012. This is very much the same question. Make sure that you write this in on your paper. This is very much the same question as the last one with a lot less blanks. All right, which one of these numbers is the rate of change and which one is the y-intercept? Which one is the starting point? Well, the starting point is 183, so this is our B. The rate of change is 9 million per year. That's always a tip-off that that's your rate of change if you see per something or other. So 9 is our rate of change. We put that in front of the X, and then this is our starting point, our y-intercept, and it would be positive because you can't have negative users. There's your equation. Much easier to do without all the blanks. Okay, so what if I give you an equation in slope-intercept form? How would you graph it? Okay, let's see. They want you to know this vocabulary too. They want you to know that parameters are the M and the B because those are changeable. Okay, and they also change the way the graph looks. A constant function is a y equal b, where you notice they don't say x equals b because x equals b is a vertical line and it's not a function. All right. The only one of these vertical and horizontal lines is a horizontal line is a function, and it's called a constant function because it never crosses the y-axis. So, yeah, make sure you write down the N. Nancy. Okay, so if I tell you that a linear function has a slope of -3/2 and a y-intercept of 4, the first thing you do is you plot the y-intercept. Well, let's go ahead and write the equation how they want it. -3/2 and then plus 4 because it's positive 4. So you would write this -3/2 x plus 4. So here's the way you do it. First thing you do is put your dot on your y-intercept at positive 4. So we go 1, 2, 3, positive 4. That's your starting dot. From there, we will use this slope to find another point. Now this is a negative slope. So first of all, that tells you that this line is a nice negative, okay? But I will also tell you that you can write it this way. With a negative slope, it doesn't matter if the negative sign is attached to the top number or the bottom number, you will get the same line. Why do we care, Miss Williamson? Well, sometimes your y-intercept is very close to the edge of a graph. And the slope with the top number negative might take you off of the graph. And so it's good to have options, okay? And here we can either go, remember this is the change in the vertical motion, this is the horizontal motion. So this is actually down 3, and this is up 3. The top number is your up or down number. If it's negative, it tells you to go down. If it's positive, it tells you to go up. The bottom number is your left and right number. If it's positive, you go right. If it's negative, you go left. So let's start with this one. This one says go down 3 and then go right 2. So from here, not the origin, from your starting point. That's a common error. A lot of kids want to go back to the origin and graph from there. No, start from the starting point. Go down 3, 1, 2, 3, and then go right 2, and you put another dot there. Let's say you had originally chosen to use this slope. How would this look different? Well, instead of going down and right, you would have gone up and left. So you would go up 3, 1, 2, 3, left 2. But do you see, before I mess this up with one of my grossly not straight handwritten lines, do you see that these are all on the same line? You just traveled one way on the line or the other. Okay, that's why we can do that. I'm going to try to draw a line. Why we can attach the negative to the top number or the bottom number. Okay, pretty cool, right? No table needed. Make sure you wrote down this D. Oh, and there's another D. 2 Ds. All right, graph a linear function with a slope of -2 and a y-intercept of 7. Y-intercept is 7, so we start on the y-axis at 7. There we go. And we know the slope is -2. So this means that we can have the negative on the 2, or we can put the negative on the 1. All right? Well, if we use this one, remember the top number tells you up or down, and negative is down, positive is up. The bottom number is left and right, positive is right, and negative is left. And if you can't remember this, think of a coordinate grid. Where are the positive numbers? They're up here and over here. Where are the negative numbers? Here and here. So negative says left and negative says down. Positive says right, positive says up. Okay. From here then, we could go down 2 and right 1, down 2, right 1, and you can do this more than once. Down 2, right 1. Maybe you want to have, sometimes you want to see where it intersects something else. And so it really will benefit you to carry this line on as long as possible. From here, we could have also gone up 2, left 1, but it takes us off the graph. So this one's not usable in this example. Okay? And then you would, with your best steady hand, draw a line. Yeah, that. Okay, so now this is where we wanted to get with this. We want to take an equation that is not in slope-intercept form and put it in slope-intercept form and then graph it. Don't forget the U. Okay. So here we have this. We want y all by itself on the left, so we need to get rid of this 12. So let's subtract 12x from both sides. That gives us -3y equals -12x plus 18, y plus because 18 is positive. Our last step is to get y all completely by itself, so we must divide every term in the equation by -3, and that gives us y equals a -12 divided by -3 is +4, and 18 divided by -3 is -6. Okay? So we know we intersect y at -6, which would be right here, and we have a slope of +4. So that's 4 over 1, which this is up 4, right 1. We could also, and we don't need to do it on this graph, but when you have a positive slope, you do still have an option, because isn't a negative over a negative equal to a positive? Right. Sometimes the y-intercept is going to be up here and you can't go up 4. So what do you do then instead? Make both the top and the bottom negative, and then you can go down and you'll be able to stay on your graph. Okay, so that's your option with a positive slope. You can do them both positive or you can do them both negative. Okay. So we know the slope is positive 4, so this is up 4, right 1 from here. Ooh, and look how they've numbered these. Each one of these is 2, so up 4, right 1. Woo-wee, that puts us in an awkward position, doesn't it? Up 4, right 1, right here. That's all I'm going to do. I'm going to try to draw this line. Not my best work. But you see what they're saying? Draw the line through the points. This is the y-intercept, -6. And then when we went up 4, right, this is the positive 1, -2 is right here. So that was the first point we graphed. It's much easier to do it with paper and pencil. Okay. Graphing constant functions. This is a horizontal line, okay? It's a horizontal line at y equals 2. And we talked about these in the last section. This one's pretty straightforward. This is a function because it passes the vertical line test. A vertical line is not a function, so it is not a constant function, okay? That's why they're only going to be giving you horizontal lines for constant functions. Check. How do you draw a graph of y equals 1? It's a horizontal line at y equals 1. Ooh, that was a pretty good line. Check it out. Yeah. Did we get all the letters we were supposed to be getting? You get that U? Okay. I must have ran out at that point. I have no more letters for you. So technically you could quit watching this right now and you would be able to get the secret word, but you don't want to miss this problem. We're almost to the end of this video. Okay. Match each graph with its function. Let's do the easy ones first. These constant functions are cake. We need a horizontal line at y equals 8. So this one is D. And a horizontal line at y equals -4. This one is C. So we're done with those two. Now, do we have one in slope-intercept form? Let's start with these ones that are in slope-intercept form. This equation would intersect y at +8 and have a slope of -3. So it intersects y at +8 and then goes down 3, right 1, down 3, right 1. This is winner, winner, chicken dinner goes right there. Okay. This one's also in slope-intercept form, so we know this one intersects y at -4 and has a positive, puff, puff, positive slope of 3/7. Well, it's got to be E, because E intersects y at -4 and goes up 3, right 7. Yeah, that E's our winner there. So now we're down to the two that are not in slope-intercept form. All right, we can put them in slope-intercept form. So we can find out at least which one's got this one's got a negative slope, it goes downhill, and this one's got a positive slope. We just need to know which one's got positive or negative slope. So 3x minus y equals 8. Let's subtract 3x from both sides. That gives me -y, which is a no-no, we have to fix that, equals -3x plus 8. Divide every term by -1 to make y positive, or you could multiply every term by -1. And that gives me y equals +3x minus 8. So which one of these intersects? There you are A. And by process of elimination, you have to be F. And you know what, guys? That's not it. I thought that was our last problem. Okay, well, no, you know what? This is our last problem, because this is kind of one they put in there as like a group project, you know, where you would work with a group of students and you would talk about this and strategize. And until I can put you in groups, we can't really do these. They want you to take the equation here. It's not in slope-intercept form. You would want to put it in slope-intercept form and then come over here and graph it on the graph. It's an application of slope-intercept form, but we're not going to focus on this right now. We're just trying to focus on the basics until things go back to normal. So we're just going to kind of skip that one. And so I was right. That was the last problem. You should have all the letters you need for the secret word scramble. And I appreciate you sticking it out and listening to me. And now there should be a McGraw-Hill practice assignment for you over on Reveal's website. Good luck with that. And if you need any help, just let me know. All right. See you next time.